Thank you. My name is Dema, and this is the Adventures of a Python Script, a talk about Python internals. So I'm a third-year software engineering student at the University of Guelph, where I'm currently doing a mobile development co-op at Wave. So just a quick disclaimer, I'm not a Python expert, and everything I'll be talking about is purely based off my research and my explorations. So what happens when you run Python code? It's fed into an interpreter and gets converted to bytecode. There are many Python interpreters out there, and you can even go on and create your own. The official implementation is CPython. It's written in C, and if you don't know which Python interpreter you're using, you're most probably using CPython. There's also PyPy, which, as you can tell by the logo, it's written in Python, and also Jython, a Python interpreter written in Java. How does CPython work? Well, it takes your code and it does a lexing, and then a parsing, and then an interpretation, and then a compilation process. If you're unsure about a few of these steps, we're going to be talking about them right now. So lexing, that converts your code into a sequence of tokens. It works directly with the parser. The parser takes these tokens and then it transforms them into a parser tree. The parser tree also acts like a syntax police. For example, if you forget that Python doesn't have semicolons and you try to do this, the parser tree will not parse your code. And then if you fix it, the parser tree will accept it and give you a parser tree. The parser tree retains all the information in your code, including the white space. After that, the parser tree gets converted to an abstract syntax tree. It's a less concrete representation of your code, and it also acts like the logic police. For example, if you put the code into a function and you try to call it with 3 as an input, it will tell you type error. You cannot give arguments for a function that doesn't accept arguments. And then if you don't include arguments, you are good. And then we go to the control flow graph. The control flow graph is an undirected graph that models the flow of a program. It's usually the last step before bytecode. So if you got to this point, you're doing pretty good. Our code here is the example of the control flow graph, but the control flow graph can have many routes. So as long as you have a point of entry and a point of exit, you can have as many different potential routes as possible. So if we look at this example, we have a simple if statement and an else condition. So our control flow graph will look like this, where you can jump depending on the condition of X. Our next step is the compilation of bytecode. Or the bytecode, where Python actually has a cool module called disassembler, where it can disassemble your code in a human readable format, so you can see what the bytecode would look like. So if we look at our example, this is what we would get if we print the disassembler. The left column is the line of what your code is at, and in the middle it kind of shows you the operation it's doing. So it's loading constant for x equals 1, and then for y equals 2, and then the third step is when it does a binary add, binary multiply, and then it pops the function, which brings us to our next thing. Python is run on a stack-oriented virtual machine, so your functions and your code gets pushed and popped off the stack. And Python's actually kind of like a 2,000-line C program that's like a switch statement, and that's really what runs your code. So back to the abstract syntax tree. As we mentioned, it's not a concrete representation of the original code, but it's an abstraction of your code that discards some details and focuses on the syntactic structure. So why is it useful? Well, you can model different linting programs and debugging programs with it. For example, let's say you join a team and you have like specific code base guidelines and of how you import modules. You want to group your imports specifically if they're like internal and external libraries, and then you also want to have your import statements before your from ... import statements, and you also want to have your alphabetically sorted imports. You would write a PyLint plugin that uses the abstract syntax tree and organizes all this. Unfortunately, 10 minutes is too long, so I couldn't include some pseudocode for that. But then you can also use it in debugging. So there's a cool open source library called Birdseye, which is a graphical Python debugger. It uses the abstract syntax tree and creates a little server on your computer where you can add an eye decorator to your function, and then you can look at the points of where the program is running and like where what the variables are at every point. And then if we take Birdseye and add it to our library and we add an eye decorator, we can tell that at the final statement our final evaluation is 9, but the step before that it's 3. So thank you for coming to my talk.